Volcanoes? They're hot, they're dangerous, and we can't stop them. But we might be getting better at predicting when they'll erupt, and that could help us to stay ahead of the danger they bring. Now, I'm sure many of you have heard about the somewhat infamous prediction that the Hunga Tonga volcano in the South Pacific would erupt in 2023. That prediction turned out to be wrong, but it was based on some really interesting science. And it wasn't the first time that scientists had predicted an eruption at this volcano. So let's talk about how scientists predict volcanic eruptions and whether or not we are getting any better at it. You don't need me to tell you that volcanoes are scary. They can cause massive damage and loss of life. So being able to predict when they're going to erupt is obviously very useful. For centuries, people thought that predicting volcanic eruptions was just not possible, until they realized that there are often some precursors that happen before an eruption. For example, there are changes in the patterns of earthquakes that happen around the volcano. As magma, which is molten rock beneath the Earth's surface, rises up toward the surface, it puts pressure on the rocks above it. Eventually, that pressure causes the rocks to break, and that creates earthquakes. Sometimes these earthquakes are big enough to be felt. Other times, they're too weak to feel, but can only be detected by instruments. There are also changes to the shape of the volcano itself. As magma moves into the upper part of the volcano, the ground above it can bulge. In some cases, the bulge gets bigger until part of the slope of the volcano breaks off, and that becomes a really dangerous landslide. Sometimes gas emissions from the volcano change as well. All of these things are potential clues for an eruption, and scientists use all the tools at their disposal to track them. They set up local and remote sensing networks to monitor earthquakes. They use satellite radar to watch the shape of the volcano, and they even sometimes take direct samples of the gases coming from the volcano. And that last one is how we know that not all volcanoes are created equal. The thing that causes an eruption is the magma inside the volcano. And magma is not a one-size-fits-all kind of material. Different magmas have different properties. And those properties affect how the magma behaves as it moves through the volcano and affects the characteristics of the eruption. For example, magma viscosity or resistance to flow depends on its chemical composition and temperature. When it's high viscosity, it's more like honey. When it's low viscosity, it's more like water. Temperature also affects how gassy the magma is. Hotter magma can hold more gas in solution because the gas has more energy and isn't escaping out of the magma as easily. So it turns out that different types of magma have different ways of behaving as they move up the volcano. Some magmas are more likely to stick and plug the vent of the volcano. Others are more likely to spill over the sides. Some are so gassy that the pressure from the gas can overcome the weight of the magma and trigger a violent explosion. Others just kind of bubble along without exploding. And all of that influences how much warning we get before the eruption happens. In the case of Mount Semeru in Indonesia, scientists noticed that earthquake activity under the volcano increased in the months before its most recent eruption in 2021. They also noticed a slight inflation of the mountain itself. So they were able to predict the eruption with several months' warning. But the same thing doesn't always happen at other volcanoes. Take, for example, Mount Semeru's neighbor, Mount Semeru. There, earthquakes actually decrease in frequency right before an eruption, and there's no noticeable change in the shape of the mountain. So you can't use the same methods to predict eruptions at different volcanoes. This is why monitoring a volcano site is such hard work. Scientists need to know the history of the volcano and the details of its previous eruptions. They need to understand the geology of the area and keep up with current research on how volcanoes work. They also need to collect lots and lots of data from the various monitoring stations and then interpret that data in light of everything else they know. It's not surprising, then, that scientists don't always get it right. The Hunga Tonga prediction is a good example. There's actually been a lot of activity in the Hunga Tonga caldera in the last couple of decades, including small eruptions. In 2014, scientists were able to observe an increase in earthquake activity and ground deformation leading up to a small eruption of the volcano. So they set up a system to monitor the volcano for signs of another eruption. In 2022, they observed some unusual activity and reported that there was a 6 to 13% chance of an eruption happening between 2023 and 2028. But unfortunately, they weren't able to collect enough data to make a smaller prediction window. And as it turns out, the eruption happened in January of 2023, just outside of the range that they predicted. But in their defense, this volcano is a little weird. It had been quiet for 30 years before 2012, and the last big eruption was way back in 1912. So it could be that there's something different going on now than in the past. Still, even though the prediction didn't pan out, it was worth making because it kept people aware of the possibility of an eruption. Because while volcanoes are beautiful, they're also serious natural hazards. Being able to predict when they'll blow helps us all to stay ahead of the danger they bring. Predictions are becoming more accurate thanks to the work of volcanologists and computer modelers who are using new techniques to analyze the data that they have. One team has developed a method that uses machine learning to analyze data from various monitoring systems, and it worked pretty well when tested against historical records. Another group has been working on improving the computer models that simulate how magma moves through a volcano. The more accurately they can model the movement of the magma, the better they can predict what kind of eruption might happen. And here's the cool thing about all of this. As scientists learn more about what causes volcanic eruptions, they can use that knowledge to improve our monitoring systems. As they develop better models, they can also try to identify which models and monitoring techniques work best for which volcanoes. So the next time you hear about a volcano that scientists think might erupt soon, remember that they probably didn't get that prediction out of nowhere. Chances are they've been watching it for a long time, and they're doing the best they can to keep people safe. Thanks for watching this episode of SCI Show News.